Hi everyone, welcome back to our YouTube channel. Today I am going to discuss types of chemical reaction. The first one, combination reaction. Second, decomposition. Third one, displacement. Fourth, double displacement. Fifth one, oxidation and reduction reaction. And the last topic, that is corrosion and rancidity. Let's watch that videos. The second topic, types of chemical reaction. There are 5 types of chemical reaction. The first type, it is combination reaction. Second, decomposition. And third, displacement. Fourth, double displacement. And the last one, oxidation and reduction reaction. Together we call it as redox reaction. Oxidation and reduction take place in a single reaction that is known as redox reaction. Now we are going to study each and every topic. First one, combination reaction. Let's check the activity first. Take a small amount of calcium oxide, or another name of calcium oxide is quicklime, calcium oxide or quicklime, in a beaker. First you take a beaker, add small amount of calcium oxide. So calcium oxide, another name of calcium oxide is quicklime, and slowly add water. In this you have to add water slowly. So afterwards you go and touch the base of the beaker. Do you feel any changes in the temperature? Yes, we feel they are releasing a large amount of heat. They are releasing large amount of heat like this. So we have to add water here. So they produce calcium hydroxide. Whatever thing it react with water, the product is hydroxide. And react with oxygen, the product is oxide. Like this, you remember it. Water means hydroxide, they form. That means water splits to form H plus ion and OH minus ion. And this calcium means calcium plus 2 and oxygen minus 2. This calcium plus calcium and OH minus, they react to form calcium hydroxide. Here it is plus 2, cross multiply that, twice will come, CaOH twice. So this calcium hydroxide is known as slaked lime. From this, what you understood, calcium hydroxide react vigorously with water to produce slaked lime. And one more thing, they are releasing a large amount of heat. In this reaction, this calcium oxide and water combine to form, look at the reactant side, calcium oxide and water combine to form a single product. Look, in the case of product case, only a single, that is calcium hydroxide. This type of reaction is known as combination reaction. How can you define this combination reaction? That means one or more reactant react to form a single product. Otherwise, simply we can say more than one reactant react to form a single product, that is known as combination. Combine to form a single product. So that is known as combination. Normally combination means minimum 2 things we need to combine. So here 2 reactants, they combine to form a single product. That is very important, single product. More than one reactants, they combine for only a single, that is known as combination reaction. Let us check the another examples also. Simple one, carbon plus oxygen gives carbon dioxide gas. Hydrogen plus oxygen gives water. You have to balance this equation. Hydrogen, 2 hydrogen and oxygen is in the reactant side 2, here only 1, put 2 over there. Hydrogen goes to 4, here hydrogen only 2, put 2 over there, and oxygen 2. Balance the equation. So nitrogen plus hydrogen gives ammonia. These all are, look at this, all are more than one reactants and a single product. Simple examples we can give. Uses of this reaction. A solution of this slaked lime produced by the reaction is used for whitewashing the walls. calcium hydroxide react slowly with the carbon dioxide in the air to form layers of calcium carbonate on the walls, layers. So this calcium carbonate is formed after 2 or 3 days of whitewashing and gives a shiny finish on these walls. So it is very interesting that look at the chemical reaction. This calcium hydroxide we are using for whitewashing the walls react with carbon dioxide in the air. They form calcium carbonate. This calcium carbonate shows the shiny appearance on the walls. Plus water is evolving. This water evaporate out. The water, write the physical state, water in the liquid state. This calcium carbonate is in the solid state. Calcium hydroxide, we know that calcium oxide is a solid form powder, and water means always in the liquid form. Solid mixed with water, that is known as aqueous. So this calcium hydroxide in which form? Aqueous form. This aqueous carbon dioxide gas, we know that is a gas. So they form calcium carbonate is whitewashing the walls. Afterwards we can see the solid form and water, there is a form. Next, look at that. In this activity, this calcium oxide react with the water to form calcium hydroxide. We are observed that large amount of heat is released. So this type of reaction, the reaction in which heat is released, that is known as exothermic reaction. Here we know that heat is releasing. So that reaction is known as exothermic reaction. There are two types of reaction, exothermic reaction and endothermic reaction. So we already studied exothermic reaction means reaction in which heat is releasing. What about the endothermic reaction? Reaction in which heat is absorbed, that is endothermic. Absorbing, here releasing. Exo, what is the word meaning? Exo means exist, that is releasing. Check the examples of exothermic reactions. First one, burning of natural gas. Natural gas contain which gas? It is that methane gas, CH4. This methane gas burning means react with oxygen. They form carbon dioxide plus water. Plus one more thing, it is there, heat is releasing. So heat is releasing, that is exothermic reaction. Second example, respiration in our body, that is an exothermic reaction. We get energy from where? From the food. So during digestion, food is broken down into simpler substances. That means that is rice, potato, bread, these all contains carbohydrates. These carbohydrates are broken down to form glucose, and this glucose combines with oxygen in the cells of our body to produce energy. Let's check the equation. Glucose, this glucose, see this H12O6, this glucose combines with oxygen, that means react with oxygen in the cells of the body. They produce energy. What type of energy? The carbon dioxide also releasing, water also releasing, and energy also releasing. Understood? That is this special name of this reaction, that is known as, in the biological term we are telling as respiration reaction. In chemistry, the heat is releasing, that is an example of exothermic reaction. Now we'll check the another reaction, that is endothermic, second reaction. We already studied endothermic reaction means reaction in which heat is absorbing. So examples in the case of endothermic reaction, example, nitrogen react, nitrogen is a gas, or react with oxygen gas to form nitrogen monoxide, NO. Nitrogen monoxide, check the balance the equation, 2 nitrogen and 2 oxygen, here 1 only, directly you put 2 over there, nitrogen monoxide gas is releasing. And what happened here? Heat is absorbing. Another cases, otherwise you can write here plus heat gives NO. And second we can write carbon react with water plus heat, they get carbon monoxide plus hydrogen gas. So carbon react with hydrogen, water gives carbon and plus heat gives carbon dioxide plus hydrogen. This reaction is known as endothermic reaction. and this gas is known as nitrogen monoxide gas. Nitrogen monoxide. One more gas, we know that nitrous oxide. Have you heard? Nitrous oxide means N2O, nitrous oxide gas. That is, nitrous oxide gas is known as laughing gas. I think all of them heard that, laughing gas, nitrous oxide gas. And here one more thing, wherever water they react means they form hydroxide. So I already explained, oxygen means they react with oxygen means it is oxide form, react with water means hydroxide form. I will show that equation. Water splits to form H plus ion and OH minus ion. Look at the case of calcium oxide. This calcium oxide also splits to form calcium plus 2 ion and oxygen minus 2 ion. This plus and minus react to form calcium hydroxide. Look at, calcium has plus 2 ion, so cross multiply CaOH twice, like this they react. Second reaction, decomposition reaction. In decomposition reaction, there are 3 types of reactions. First one, thermal decomposition. Second, energy is supplied in the form of electricity, so we call it as electrolysis. Third, same energy is supplied in the form of sunlight, so we call it as photolysis. So there are 3 types of decomposition: thermal decomposition, electrolysis and photolysis. Let's check the activity. First one, thermal decomposition. Take a ferrous sulfate crystals in a dry boiling tube. Dry boiling tube means a dry test tube, no need of water molecules. Very important thing, remember, dry test tube. Take a ferrous sulfate crystal. Some crystals are the ferrous sulfate. Let's look at that. FeSO4 ferrous sulfate crystal. The color of the ferrous sulfate crystal is pale green. Very important, the color pale green is the color of the ferrous sulfate. Now what you have to do? Heat it. Heat these ferrous sulfate crystals. Observe the color change. What happens? This ferrous sulfate, when we heat it, it is changed into ferric oxide, Fe2O3. The pale green changed the reddish color. Plus, there is a smell which comes in the odor of burning sulfur. So where sulfate is there, the gases releases are sulfur dioxide and sulfur trioxide, this gas. So carbonate is there, carbon dioxide gas, nitrate is there, nitrogen dioxide gas, sulfate is there, sulfur dioxide and sulfur trioxide gas. So pale green changed to reddish color, and this sulfur dioxide and sulfur trioxide gas are white fumes are coming. We can see the white fumes are coming out. So that is gas is known as sulfur dioxide and sulfur trioxide. And in this reaction, we can observe that this single reactant, look at the single reactants break down to form a more than one product. That is known as decomposition reaction. So simply we can define it. The single reactant decompose. Decomposition reaction is there, so we call it as decompose. Decompose to form more than one product. In combination reaction we studied, that is more than one reactant combined to form single product, just opposite of this combination and decomposition. So let's check the another activity. This is the first activity. Look, take a calcium carbonate powder, same in a dry test tube. Take calcium carbonate. You have to heat this calcium carbonate powder. It changes. Okay, these all are solid form. Here also crystal means it is solid form. Calcium carbonate is also in white crystal form, so it is solid form. Heat it, we get calcium oxide and the carbonate. Which gas is releasing? Carbon dioxide gas is releasing. So this white color, again the product is white only, but we can see the fumes are coming, the colorless fumes are coming, that is carbon dioxide gas. So this also a second type of reaction. So look at that, we are heating. So heating, thermal, from the word meaning, thermal means what? Heat. So from this thermal meaning we can know that it is heating. So that is known as thermal decomposition. And third reaction third reaction, that is same, you take a dry test tube, add lead nitrate. Instead of ferrous sulfate, we have to add lead nitrate. The color of the lead nitrate is white. Why PbNO3 twice? Because lead is +2 ionic state, nitrate is -1, cross multiply PbNO3 twice. Lead nitrate in a dry test tube, same way you heat it. What we can see, it's very nice to see this the observation, the emission of brown fumes, like the brown fumes are coming, that emission of brown fumes, and these brown fumes are known as nitrogen dioxide gas. Look, lead nitrate on heating gives lead oxide. Lead oxide is solid form plus nitrogen dioxide gas, and one more gas is there, that is oxygen gas. Nitrogen dioxide gas, what is the color of this one? Brown fumes. So this white color changes to, this lead nitrate is white in color, it is changes to yellow color, and moreover we can hear a crackling sound. Crackling sound, that is nice to hear, that one crackling sound, and white changes to yellow and reddish brown fumes are coming. So this and oxygen gas is there. So what is the color of nitrogen dioxide gas? Reddish brown fumes. These three reactions are known as thermal decomposition reaction. And one more gas we already studied, that you all of them knows, that N2O, that already I explained, that is laughing gas. Look at the main product in all these cases. Main product, these all are oxide form. Ferrous sulfate, product is ferric oxide. Calcium carbonate, product is calcium oxide. Lead nitrate, product is lead oxide. फिर byproducts are that sulfate comes to sulfur dioxide, sulfur trioxide, carbonate changes to carbon dioxide gas, nitrate changes to nitrogen dioxide and oxygen gas. Like this you remember it. It is very easy to remember. Second decomposition reaction, that is electrolysis. What is electrolysis? Energy supplied in the form of electricity. Let's perform an activity. Take a plastic mug, drill 2 holes at the base. At the base, now here you have to fit it rubber cork in these 2 holes. Fit like this rubber cork. Next, insert carbon rods in these rubber cork stoppers. In the 2 carbon core electrodes we need this. Next, connect these electrodes to a 6-volt battery. 6-volt battery. Fill the mug with water. Main thing you have to remember, so these electrodes are immersed. Like this you have to fill this water. These electrodes are immersed then, and it is not necessary, but you have to add 1 drop of dilute sulfuric acid. Now take 2 test tubes filled with water and invert them over 2 carbon electrodes. Now switch on this current and leave the apparatus for some time. What you will observe? The formation of bubbles. So many bubbles are this one. The formation of bubbles on both the electrodes. Afterwards it fill this test tube also. Then look at these bubbles cases. This volume of the gas collected in different, these 2 test tubes are different. The volume collected in these 2 test tubes are different. These bubbles means what? This water displaces. Water displaces means it displaces to form hydrogen gas and oxygen gas. Once the test tubes are filled with respective these gases, remove them carefully. Test these gases one by one. First you bring the lighted candle near the test tube. What happens? Well, we can hear the pop sound. that gas is known as hydrogen gas. So you find that another one, of course we know that it is an oxygen gas, but this one test tube filled more gases and the second test tube filled less gases. So which test tube filled more gases and which gas is there? That is a hydrogen gas. Look at this, balance the equation. H2O, here hydrogen 2, oxygen 2, here oxygen is 1 only, put 2 over here, so both hydrogen goes to 4. Here hydrogen 2 only, put 2 into 2, 4, hydrogen balance. Now check it, the oxygen also balance. And here 2 hydrogen is there and 1 oxygen. So they fill in the ratio, very very important, they fill in the ratio 2:1. Why they fill? Which gas fill in the ratio of 2? That is hydrogen gas, and oxygen gas is 1 only, because it contains, one question always it comes that it contains 2 moles of hydrogen. Why it fill in the ratio of 2:1? Because hydrogen contains 2 moles of hydrogen are there, and here 1 mole of oxygen, so it fill like this. And another reason it is the hydrogen is light in weight, so it fill more. Third decomposition reaction is known as photolysis. What is the word meaning photo? Photo means light. So through sunlight, energy is supplied in the form of sunlight. Here also check the activity. Take a silver chloride in a china dish, like this. Take a silver chloride. Silver chloride is a white in color. Why AgCl comes? Silver is +1 ionic state, chlorine is -1 ionic state, so AgCl. And place the china dish in sunlight for some time. Allowed to keep in the window side or allowed to keep the sunlight here. So observe the color of changes. So what happened? This white silver chloride changed it to gray color. That means it splits to form, it decomposes to form silver and chlorine gas. This silver means white changes to gray color. That chlorine means it is a gas, it evaporate out, it escaped out. So white silver chloride changes to gray color. So very important that silver chloride decompose to form this silver and chlorine. That reaction is known as photolysis in presence of sunlight. You have tried like this, in presence of sunlight. That is known as photolysis. The same way, and one more reaction is the silver bromide. Silver bromide in presence of sunlight, they decompose to form silver and bromine gas. These above reaction, these two reactions are used in black and white photography. Early time the photography is of black and white only. There we are using this black and white photography. And here also what happens, we can see the reaction in which heat is absorbed. They are absorbing the heat and decompose. So this reaction is also called endothermic reaction. Endothermic reaction. Third reaction, displacement reaction. Here also let's perform first activity. Later we will study the definition of displacement reaction. Take an iron nail and clean them with a sandpaper. And another one we need a 2 test tube, and fill copper sulfate solution in both test tube and mark it as A and B. This is a copper sulfate solution. What is the color of copper sulfate solution? Bluish color. And another name of copper sulfate is known as blue vitriol. Another name of copper sulfate. Next, what we have to do, dip the iron nail with a thread in this copper sulfate solution. I am dipping in the solution B with a thread we need like this, and after 20 minutes take out this iron nail from the copper sulfate solution. Compare the intensity of these two solutions, copper sulfate solution. Compare it, the color of iron nail dip, and take it out this iron nail like this. We can see that the reddish brown coating on this iron nail. How it happens? This iron react with copper sulfate solution, gives that this is blue color only. Compare this color, this blue color changes to pale green color. blue changes to pale green. And this iron nail, it is silvery color. We know that iron nail contains silvery color, but it is outer coating becomes reddish brown. So what happens? This iron react with sulfate to form FeSO4. Fe, what is the color of iron sulfate or ferrous sulfate? That is pale green. Plus copper is deposited. This in this iron nail, copper is deposited, and this solution changes to pale green means what happens? This copper sulfate changes to iron sulfate. So how can we define this one? Displacement reaction. More reactive element. Iron is a more reactive element displaces the less reactive element like this. They displaces less reactive element from its compound. Here iron is more reactive than copper from its compound, so it displaces. We already know that the reactivity series: potassium, sodium, calcium, magnesium, aluminium, zinc, iron. Then afterwards only the copper comes. So iron is more reactive than copper. How can you define this displacement reaction? More reactive element displaces the less reactive element from its compound. Here iron is more reactive than copper, so copper displaces from its compound. Another examples also, take it as another example. Zinc react with copper sulfate gives zinc sulfate plus copper. Here zinc is more reactive than copper. Let's take it as lead. Lead react with copper chloride. These are all in aqueous state. What happened? This one we get lead chloride plus copper is deposited. Like this they react. Fourth chemical reaction, double displacement reaction. Here also let's check the activity first. Take a small amount of sodium sulfate solution in a test tube. Sodium sulfate Na2SO4. So you have to take small amount here, and one thing you have to remember, this is a colorless solution. First you take a crystal and add some water, you have to make a solution. So in which form? It is an aqueous form. And in another test tube you have to take barium chloride solution, barium chloride BaCl2, that is also in aqueous state. Both are colorless solution. Then mix this solution like this. So what do you observe? You will observe that a white substances which is insoluble in water, we can see that is insoluble substance is known as white precipitate. We already studied in the first part that yellow precipitate. Here we can see the white precipitate, and if we added, that formation is immediate formation of white precipitate. So how the reaction occurs? Look at that, barium and sulfate to form barium sulfate. This barium sulfate is a precipitate. Precipitate we can mention as solid, otherwise down arrow. Two forms, any one you have to use it, down arrow or solid form. And this sodium and chlorine to form sodium chloride. This sodium chloride is a colorless solution, it float on this solution. So look at formation of precipitate. So it is another name of this reaction is known as precipitation reaction. So double displacement is also known as precipitation reaction. So look at both. Another one very important thing you have to remember, both are colorless solution. If you add, the formation is immediate formation. So suddenly they have to see that white precipitate. White precipitate means it is insoluble in this water, insoluble in this solution. So barium sulfate is a solid form, and both so all are in this. This is solid form and this one it is aqueous form. And how can you differentiate displacement reaction and double displacement reaction? In the double displacement, look at the reactant side, both are aqueous. What about the displacement reaction? Displacement, one it is a metal, in the reactant side one it is metal and another one it is an aqueous. So like this way the equation we can recognize what type of equation it is. It is whether it is a double displacement or displacement. In double displacement, in the reactant both are aqueous, and in the case of displacement one it is metal, that is iron metal, zinc metal, lead, like this we used. So this is the way. Then how can you define this double displacement reaction? Look at exchange here, one another also. There is exchange of ions between the reactants. The exchange of ions between the reactants are called double displacement reaction or precipitation reaction. Look at here, their exchange, here also they exchange their ions. The last reaction, oxidation and reduction reaction. How can you define this oxidation? Oxidation means gaining of oxygen. Gaining of oxygen is known as oxidation, and reduction means just opposite, loss of oxygen. And one more definition is there here, loss of hydrogen is known as oxidation, here gain of hydrogen is known as reduction. So like remember it, gaining of oxygen is known oxidation. Oxy means oxygen, they need oxygen, so gaining of oxygen is known as oxidation. Here there is no need of oxygen, so loss of oxygen. Otherwise gain of hydrogen is known as reduction, hydrogen they are gaining, and in just opposite comes oxidation, loss of hydrogen is known as oxidation. Here also let us perform an activity, very simple activity. Take a china dish, add some copper powder. We can see the copper powder like this crystal form, and what is the color of copper? Brown color, and you have to heat it. What happens? This copper, heating means what is the meaning? It is react with oxygen to form copper oxide, copper to oxide. That means ionic state is 2, so it is cupric oxide. Therefore copper we know that is brown color. When we are heating this one, it changes to blackish color, black. So what is the color of copper oxide? Blackish color. Very important, remember this part. Copper oxide, the color of copper oxide is black. Then another cases, if you are adding a hydrogen gas in this copper oxide, what happens? This one, look at that, hydrogen gas is passed through a copper oxide and the surface turns brown. This surface turns brown, the reverse reaction occurs. So copper oxide adding hydrogen gives copper plus water. That means reverse reaction takes place, means it changes to brown color. Again they form a copper. In this reaction, check it out, copper oxide, they form copper. Product is copper. Copper oxide changes to copper. That means from the reactant it loses the oxygen. So losing oxygen means, loss of oxygen means, that is known as reduction. And in the case of hydrogen, hydrogen got oxygen in the product side. So gaining of oxygen is known as oxidation. So in this reaction, oxidation and reduction take place together. So we call it as redox reaction. So oxidation and reduction take place in a single reaction is known as redox reaction. Another cases, in the reduction is happen here, and here it is oxidation happen. Substance which can bring about the oxidation, so that is known as oxidizing agent, and substance which bring about the reduction of other substances is known as reducing agent. So in the cases their reduction is happened, so this copper oxide is known as oxidizing agent. And in the case of hydrogen, that is oxidation is happened, so it is known as reducing agent. How we can check the oxidizing agent and reducing agent? Only in the reactant side, so don't look at the product side. So copper oxide, these substances, how oxidizing agent means substances which can bring about oxidation. Substances which can bring about the oxidation of other substances, that is known as oxidizing agent. Substances which can bring about the reduction of other substances, that is known as reducing agent. So which one take place, the reduction, that is an oxidizing agent, and where it happens the oxidation, the reactants, that is known as reducing agent. Let us perform the another example. Zinc oxide react with carbon, they form zinc plus carbon monoxide. Look at this, zinc oxide changes to zinc in the product side. The oxygen, the loss of oxygen, so it is known as the reduction. Carbon, they gain oxygen in the product side, so it is oxidation. So these both oxidation and reduction take place together, it is known as redox reaction. And which one is the oxidizing agent and which one is the reducing agent? Zinc oxide is an oxidizing agent and this carbon is known as reducing agent, because oxidation happens here, so it is a reducing agent. The last topic we are going to study from this lesson, that is known as corrosion and rancidity. First, corrosion. How can you define this corrosion? We already know that the iron articles are shiny when it is new, but get coated with a reddish brown powder when left for some time. What is that? This is known as a rust, that is rusting of iron. Rusting of iron is known as corrosion. Simple, we can say rusting of iron is known as corrosion. That means when a metal is attacked by substances such as moisture, acid, etc., it is said to be, we call it as corrosion. That is iron react with oxygen to form Fe2O3.XH2O. This is known as rust. What is the formula of X? Means any number of water molecules. So iron react with oxygen, that is moisture, they will get a iron oxide, that is known as rust. Another, in the case of silver, we can see a black coating on the silver. That is that means silver attack the sulfur, they form silver sulfide. So silver sulfide is a black color coating, so that is a corrosion happening in the silver. And what about this copper? Copper, we can see a green color coating on the copper, that is another corrosion. Copper, they form copper carbonate, that is a green color coating happen in the that is copper carbonate. These are all rust, corrosion happen in the metals. What are the preventive method? We already studied in the lesson, metals lesson, that is oiling, galvanizing, greasing, alloying, etc. Next one, it is rancidity. What is the meaning of rancidity? When the substance is made up of oil or fats, otherwise fats are oil, these oil fats react with oxygen. Otherwise we can write it as it happens, the oxidation happens, react with oxygen to form bad smell and taste. So that is known as rancid, and this process is known as rancidity. Again, once again, the substances made up of oil or fat react with oxygen or oxidation to form bad smell and taste. That is known as rancid, and this process is known as rancidity. If react with oxygen or oxidation, if it is not mentioned, the answer is wrong. React with oxygen or oxidation, you have to mention it, otherwise rancidity definition is wrong. And what is the preventive method? How can you prevent this rancidity? We know that substance is made up of oil, fried items. We kept in 1 or 2 days, there is a bad smell and bad taste is there. That process is known as rancidity. And what is the preventive method? We have to keep it that in the chips packet or wafers packet, what they flush nitrogen gas. They flush the nitrogen gas. That means these nitrogen gas make a outer coating to avoid the reaction with the oxygen. So that is airtight one. Another cases, we have to keep airtight container. Another preventive method, or adding any preservatives. These are all preventive method of rancidity. First one, you flush the nitrogen gas in the chips packet or wafers packet. Another cases you have to keep it in an airtight container. And third one, add preservatives. These are the preventive methods. The portion over. This much only.